Welcome everyone. In this tutorial, we'll go through how you can integrate, a bunch of software tool, algorithm, and data. And this includes a cloud computing platform, which is an open source cloud environment, which is provided by Google for academics, research, community, and for educational purpose. It's actually free. It's a powerful analytic tool which is called Google Earth Engine, and you may have heard it or used it before if it's new to you. So Google Earth Engine is a cloud computing environment where you can analyze, visualize large scale, planetary scale, geospatial data and big data. And the other component, what we will see in this tutorial is so the Earth Engine environment has two components. It has data. It archives a large volume of data, including satellite data as well as geospatial and physical geophysical data. And you can also do some analysis on the platform. If you go to googleearthengine.com and in the home page, you can actually, let me go back to Earth Engine, and you can go to the main Earth Engine website, and you can go to platform and then code editor. What it does is you can write your own code. In this case, a JavaScript code. And there's also another version which we'll not be covering in this tutorial. There's a Python, code editor, which is called the Python Earth Engine Python API. And so for this example or tutorial, we'll be focusing on the JavaScript API. So in the JavaScript API, you can use this code editor API or playground, where you can write your script here, and you can monitor progress here, or just debug, and also finally you can visualize your output. And so we'll be using Earth observation data. We'll be using cloud computing, and mainly we'll be using a machine learning classification algorithm. And so we'll be using a random forest classification algorithm, which will be going in depth in this tutorial. And to use Landsat 9, the newest satellite data from the Landsat 9 sensor, and we'll apply a classification or machine learning algorithm using this cloud computing environment, and generate a land use land cover map using or just generating our own training data set for any part of the world. So in this case, we'll use a sample site. But you can apply this to any location on Earth. Okay, so let's get started. So the first thing is, we'll be using Landsat 9 data, and let's just look at the data on Earth Engine. You can go to datasets, and you can go to Landsat here, and within the Landsat collection, you have Landsat 9. Landsat 8 and Landsat 7, and all of the legacy Landsat sensors. So in this case, we'll be using Landsat 9, the newest sensor. And the Landsat 9 satellite has two instruments, the TIRS and OLI, and the thermal and the visual instrument. And on Earth Engine, you have three different data sets. If you look at Landsat 9, you have three different data sets. The first one is just a raw image, and the second one is top of atmospheric reflectance data with some atmospheric correction. and the surface reflectance, was radiometric correction, and the surface reflectance data has gone through radiometric correction and atmospheric correction. So this is, the most intensively processed or pre-processed data set. So we'll be using this for our case, for our tutorial here. If you click here, surface reflectance Landsat 9 data on Earth Engine, you have the data availability and the provider, in this case USGS, and also the image collection. You'll be using this to access using programmatically or just your JavaScript code. Okay, and so yeah, let's get started. Let's just get into coding. So let's just open a new code editor here, and if you don't have access to Earth Engine, I assume most of you have, but in case you don't have Earth Engine account, you just go to the main Earth Engine website here and click sign up. And in the sign up, you just request access, and then most likely Google provides you access for educational purpose or training or research purpose, non-commercial use. Okay, and you just sign up, provide your email, and then write a brief description of what you need that, mostly for educational or research purpose, and you can get granted access. Okay, so let's get a deep dive into the code. So we have, we'll do a lot of processing here. So the first one is to, download the Landsat data and then generate our training, data set, because we're running a supervised classification or a supervised machine learning, classification or algorithm. And then we'll do that, and we will build our machine learning classification and apply that classification to our training data set, and then apply that to our image, and finally generate a land cover classification. Okay, so the first thing is to actually let's just give it a name to our script. I'll just call it random forest classification algorithm, or I would say supervised classification using Landsat 9. Okay, so we'll be using Landsat 9 data in this example, and so to start with, so step one is I'll load Landsat data. Okay, so we have seen the Landsat data set here. I'll just copy that, and let me just clear that. So copy that image collection and then right here. So and what this does is load Landsat 9 data. Okay, and this is our image collection ID, but before that I'll just create a variable. JavaScript requires you to declare a variable, so I'll declare data set, and I'll just simply call that Landsat 9 image collection. And because it's a long time series and it's a larger domain or spatial coverage, we need to subset it either both spatially and temporally, right? So I'll filter by date in this case, and I'll filter date. I'll apply filter date, and I'll provide a date stamp here, start date and end date. Okay, so my start date would be, this is the newest Landsat data or sensor Landsat 9 data, so 2022 January 1st, and the end date for this time series would be, I would say, I'll open a single bracket a single quote, sorry. And 2022 here, in this case, I'll just extend to the month of May. That should be fine. And I'll also filter by a subset region, because this is a large data set. This is a global or planetary scale data set. So we need to do some sort of filtering, right? And so I'll apply filter bound function. A filter bound function will create a subset, or just not necessarily clipping, but extracting the data within that subset region. Okay. And the other important thing is I will also need to apply cloud filtering. If you don't filter a cloud, it would be, garbage in, garbage out. I mean, if you run your model with an image that is not cloud masked, the result will be misleading. So you need to apply cloud removal algorithm or application before you do any serious analysis. Okay. So I'll use the filter metadata approach to mask cloud contamination or cloud contaminated pixels. So filter metadata, and I'll open a single quotation. I'll apply cloud cover, and I'll use less than, and let me just actually change that here. And I'll use about 10% of the data. So what this means is that use anything that is cloud contaminated, anything that's less than 10% of the pixel cloud contaminated. Or I would select cloud contaminated pixel less than 10% of the pixel area. And so this will give us a little bit clearer or cloud free image collection for our study region. Okay. And before we execute that, we have said we're gonna filter by filter bounds or region of interest. So I will go ahead and choose. So let's just select here Ethiopia as an example. You can search here, and maybe just somewhere here. This is Lake Tana, the source of the Blue Nile. So I'll just use this geometry function to create my test site here. I'll just create a geometry, and I'll rename that as ROI, and I think that should be it. And if I execute my code here, if I run that here, let me just zoom in a little bit so that you can see the script a little bit more. And if I execute that, so it will just zoom in here. So the next step is to actually display the Landsat image that we have imported, right? But one other function that we need to apply is that rescaling. So to convert the image into a proper range, right? So let's just write a function that applies the scaling factor. And so the function that we are writing is apply scale factors what it does is it just converts the surface reflectance value into a proper data range. And then we'll the function will pass an input for this function, that's image, and we'll open a curly bracket, and we'll close that curly bracket. Okay, and within that we'll write our variable here. So because the Landsat 9 sensor has two instruments, the OLI and the optical bands as well as the thermal bands, we need to create that for both of these bands. So the first one is optical bands, right? Okay, and for the optical bands, apply pass image, and then select surface reflectance bands, SR B, and then after that just multiply that by a value, multiply by a value which is provided 0.00027.5, and then add minus 0.2. Okay, now I'll close this, and the second is for the thermal bands. I can go ahead and then copy paste that and then just change the parameters, right? Instead of optical, I'll just write thermal here, thermal bands, and the same applies the surface reflectance bands, and then multiply by a different factor here. Instead of that, I'll multiply by 3418. Don't worry about this. This is provided with the data set, and 02. I'm just getting this from the Landsat data set product information. Okay, so 149.0. all right, and next I'll just return the image. So my output would be image, and then I'll add bands, and we have the optical bands, right? We'll just add the rescaled version here, and then we'll add null and true, and the other one is just add bands. And for the thermal, right, I'll do the same for the thermal bands. Okay, and next we'll close that, and I'll just close the curly bracket. I can add this here. Okay. Perfect. Okay, this is our function. So what it does is it will just take the image, each image, either optical and then thermal, and apply by scaling factor. That's just simply it. Okay. And next step is actually to apply this function to the image collection we have already created, right? And I'll just declare a variable called rescale and call dataset here. I've already imported the Landsat 9 image collection, and by using a map, I'll call this function the rescaling function. Okay, what it does is it will apply or map it to every image in this image collection. So this function will be applied, and then semicolon to close my JavaScript statement. And the next thing is just to actually, because this is an image collection, we'll just run some sort of statistics to generate a single image out of the image collection. Okay. So our image is, we'll call this rescale, and calculate the median. All right. And finally, let's just create a visualization parameter here. I'll call it visual and visualization, and open a curly bracket, and I'll call bands, and then provide each band that I'm using for this visualization. So I'll just have a surface reflectance, SRB4, that means band 4 of the Landsat 9 B4. And the next, just this is to generate a true color composite, right? So I'll copy and then paste and just change the band number, right? And then band 2. And the next visualization parameters and the min max, right? And the minimum is 0, and the maximum value for that, we have rescaled this, so now it should be properly it should give us a proper surface reflectance range or value. And next step is to actually visualize the Landsat data using, we'll call this image and then apply this visualization parameter and visualize the Landsat data. Okay, that's the first step, just importing and then cloud masking and visualizing the Landsat data. We are not yet through the machine learning classification or anything like that, so we're pretty early in the stage. So we'll use a map, add layer, and we'll call this image here. This is the Landsat cloud mask Landsat image, and so we'll clip it by, actually not clip it here, and so I'll call this visualization parameter here to generate a true color image composite of the Landsat 9 image, and then I'll call it Landsat 9 here, so that I can remember when it's displayed here. I'll just remember what the name of that map is. Okay, and to adjust the zoom or the zoom level or the center, we can use center object as our ROI. We have already created our ROI, right? So now let's there's something here we need to fix that. Okay, just we need we forget a colon here, that's why we're having this here, and this should be good. Do we have any error here? Okay, so here minimum, maximum. This looks good. And we have some error here. Let's just fix that. So what's going on here? Okay, this is the error. We're not supposed to assign an equal value. That's why you know, the code editor is just giving us some error. Okay, so we are having an error here. Let's see what's going on here. Rescale median is not a function. Okay, why is that? Let's just debug that. So it's saying that rescale is not a function. So how do we fix that? Okay. Any error in our code? Let's just check it. Datasets. Okay, dataset. Map applies scale factors. Right, scale factors. Okay. Image is equal to rescale. Oh, okay. Rescale median. Okay, median. Okay, we have a typo here. Maybe that's why. Okay, perfect. We have some typo here. That's why we are having error. Hopefully this will go away when we execute this time. Perfect. So now let's visualize the our Landsat image. Oops, it's pretty dark and something is going on here. Let's visualize what's going on with this image. So it's not applied the scale factor. Okay, probably that's the issue here. It's just dark. So the reason is that it's not applying the scale factor properly. Okay, so let's just fix that again. Okay, it should be something here. And let's make sure that this is correct. Okay, so it's because we have four digits here, and that should work fine. Okay, let's try it one more time. Here we go. Now we have perfect. You see that one single error can create a problem, right? So now we can just choose this pan to move, you know, your image, and so now we have, what we have done technically is, you know, in this script, applied a scale factor and applied some cloud removal and subset it with our own steady region, and just generate a, you know, a visualization using some true color composite. Okay, so true color composite is just one way to display satellite image, which mimics the true color composition as you would see it on the ground, right? Like, you know, vegetation cover green, you know, soil, some, you know, brown or you know, yellowish color and things like that. Okay, it's not exactly as you would see it in reality, but pretty close. Okay, all right. So, and the other thing is, this image is, you know, a pretty clear. You don't see, you know, cloud contamination or things like that. And so this is you know, Lake Tana, the source of the Blue Nile, and this is a city, Bahardar city, and some agriculture area. And so you can see some vegetation cover, for example over here, some forest cover. So you can see almost everything. Okay, now the next step is to create a training data set. So to do that, we'll create a training data set, and then after that we will merge the data set. And so this part of the script will do the merging, but before that, let's go ahead and generate our training data set here. Let me just load the Landsat data here, and this is our Landsat 9 layer. We have generated a cloud-free image that we have processed of the Landsat 9 image. And let's just capture our training data. And if you look at here, so when we generated training data, that means the land cover classes for the supervised classification, it will automatically generate the classes here. So let's get started. So we have a region of interest, that's this, and I'll go ahead and create the other land cover classes. I'll just click this point data set here, and I'll just create a new layer. So we'll create a point database here, and I'll just name it water. And instead of geometry, I'll call it feature collection, and class value is 0. And I'll just give it a blue color here. And so my water class is created here. So this is a lake, so I'll just go ahead and capture as many data points for the water class. So it automatically generates the data points as I click here. So I have about 5 training sample points for water class, and I'll just drag it here, zoom in here a little bit, to make sure that I don't have other mixed classes. I'll just generate the water class within this lake area, and I'll just move it to the other part of the lake here. We have about 30 data points, so this should be good. And I'll go ahead and create the next training class. In this case, I'll create a new layer here, and I'll rename it to urban. And instead of a geometry again, I'll choose a feature collection, and I'll add a property value. Again, it's a class, and I'll provide a value 1. And I have already created that urban class. And let me just go zoom in here. This is the urban area. So I'll just capture some data points here, and I can also remove the Landsat image and overlay the Google high resolution image if need be. And so these are some building structures, and I'll create as many data points as possible to do a representation of the urban areas here. So I have about 30 data points for the urban class, and I'll move to the next class, and I'll create another class here, and that one is a forest class. Okay, and I'll create again a class, that's the property name, and then class value 2 for a forest class. Okay, let's create a forest class, and So for the forest class, I'll just create here and highlight the forest class here. And actually, I'll just zoom into some of the green areas. For example, here, I'll just change the color here to green. So I'll highlight the forest class here, and let me search for another area within the Landsat image that seems like a forest. Okay, over here we have pretty dense forest cover, right? So I'll just go ahead and then click the first class and then generate my sample here, about 30 data points, and this is just a sample. I mean, if it's a real training data, you would need more representation, spatially or geographically, but for this tutorial this should be suffice or enough. Okay, and the next class is a crop or agriculture, so I'll just create that here. I'll name it crop, and geometry, and I'll add the class, and I'll add value 3. I'll make it actually something like yellow. All right, and so agriculture is pretty, I mean, it's tricky, so let's zoom in here. So all of this area is agriculture, cropland, right? So let's just then check the Google image and then open the satellite image. You can see that all of this area is a cropland, right? So when you have a Landsat data, it's not that much clear, but if you zoom into the Google high resolution Google image, you can see all of this cropland or agriculture area, right? It's not currently, it doesn't have crop, but it's looking at the shape and pattern, it looks like agriculture. So I'll just go ahead and generate as many data points. I'll highlight it here as possible here, and generate all of this is a cropland area. To get a more representation, I'll just go some other areas. Okay, we have about 30 data points. Should be fine. And the last class is a barren class. Okay, a barren class for some open soil or some rock type in this case. So since we have only about 5 classes, so I'll just include that barren class, and again I'll add a class and value 4 and maybe a grayscale, something like this. Okay, gray color rather. And some of this area would be, let me just open the Landsat image rather. If you look at here, it's different from a cropland, so maybe this is an area. This looks like a barren. Let's just double check. Let's remove the Landsat image. So this is like some barren area, right? It's not agriculture, it's not crop or anything, grass or vegetation, so typical barren area, right? So I'll go ahead and capture as many data points as possible here, and once I have about 30 data points, I would stop there, since it would be enough in terms of my training data, right? So now we have all of the training data sets so that we are able to run this classification, right? So I'll go ahead and then execute this so that we have and then also print that training. So what we are doing here is just merging all of these separate training classes into one single file. I'll go ahead and execute that. And so we have that feature collection, and so we have the different training samples here. If you want to export, you can export this, but in our case we don't need to do that. And the next bit of code is to actually overlay the training data set with the Landsat data. Okay, I've already written this script. I'll just uncomment that. And so if you look at this here, so I'll provide the label. So as you remember, in the training class database, I provided class as a property, right, for each of the training values. For example, for water we provided 0, and for urban area 1. So this is our response variable in the classification. And also our independent variables or predictor variables of the machine learning classification will be using the Landsat 9 bands. We have to define the different bands that we'll be using. So we'll be using all of these bands, the optical bands. We're not using the thermal band in this classification, okay? So band 1, band 2, 3, 4, 5, and 7 of band 9, okay? And so from the image, from the Landsat image, we'll select only these bands, right? That's what this line of code is doing. And this will be input. So we'll input in our model only the the bands that are selected here. And next, what this bit of code is doing is generate or extract the Landsat band values for all of the training data points, right? For water, for urban class, and for forest, crop, as well as barren classes, will extract the Landsat band values for each of those data points, right? And after that, we'll split the data into training and validation data. So the first one is training data, which is 80% of the data, and the other one we'll keep it for evaluation or assessment, accuracy assessment. So 20% of the data here. So let's go ahead and execute that. So now we have 20% of the data is withheld for evaluation, and we'll run the classification with train set with 80% of the data, okay? And the next step is actually to run the classification. We have a random forest classification. So this is this chunk of the function will pull the a random forest classifier here. We call it a simple random forest, and this is an Earth Engine built-in machine learning algorithm, and it's a built-in Earth Engine function. It does have 3 parameters. The first one is a training data. So the train set this is our train set, right? And the next parameter in that model is the label, which is the class. That means our response variable, right? Or the training values. And the last one is the predictor variables or independent variables, which is in this case the Landsat bands that we'll be using to classify. So when we run this, we'll build the model, the random forest classification model, okay? And after that, we'll apply the model here, the classifier, on the Landsat image, so that we'll have not only a tabular model formed, we'll actually run the model, we'll apply that into a Landsat image, so that we'll have a final land cover classification, a raster image, okay? And let's go ahead and execute this. So when we execute, we'll have our model here, classifier, and also apply that model. Here's the classifier, the same classifier here. Apply that model to the Landsat bands so that we'll have a final classification map. And the last bit of code is to actually display the the classified image within some land cover class visual parameters here. Actually, I don't need to clip this because my region of interest is a point data, and so I'll pull this classified image, which is a land use land cover classification, and I'll provide the color palette here, a land cover palette. I'll just call it here, and a minimum and maximum value. These are the training land cover classes we have provided, and also here classification name. When I execute this code, I'll see that final map here, and let's go ahead and execute that. So when I execute that, I should be able to see my classification image here shortly. Okay, so this is our classification land use land cover classification map for our study area, which is not a perfect map, because the accuracy of your classification is dependent on the quality of your training value. So for the demo purpose, I've just generated some sample, just some example sample training data points. So this is not the best accurate land cover classification, but this is just an example to show you how you can do that. So if you look at the Landsat image, you can see the water area. We have generated that fairly accurately, and the other land cover classes are pretty close but not perfect, because again our training data points are only about 30 data points. So to generate a pretty high highly accurate or robust classification, you need more training data points. Okay, so this is our classification map using machine learning or random forest algorithm with our training data set, as well as a land cover, a Landsat 9 band. And the next bit of code is to generate actually some sort of accuracy statistics. As I've mentioned earlier, we have separated the training and validation data set. Now we'll run a confusion matrix here using this function to evaluate the accuracy of our model, which is not a perfect one, but let's see what the accuracy. So the overall accuracy is 95%. Actually, it's a pretty good one, right? So now you can evaluate quantitatively the accuracy of the classification, right? You can also generate producers and consumers accuracy values here, 85%, 100%, and things like that. You can use these, you can export these numbers and just generate some sort of table for your publication, things like that. And then the last bit of code is actually to export this land cover classification map and open it in other geospatial software like QGIS or ArcGIS or MVN, what have you. Okay, so if you run this and this will export your land cover image into your Google Drive. So if I run this, it will export it to my Google Drive, and then I'll just click run. It will automatically export this exact classification image onto your Google account, your Google Drive. And assume that you have a Google Drive, so you can go ahead and then just click it from your Google Drive and download it and use it in your other geospatial softwares if you need to. And that's how you run a machine learning or random forest classification algorithm on the cloud using Google's cloud environment. and the latest Landsat 9 satellite data.